Hi guys, it's Miss Griffin back with you today. We're taking a look at Unit 8 Skill 3 where we're talking about coordinate proofs again, but this time we're proving not a shape. So in this case, sometimes you might have to prove that it's a rhombus but not a square, or a right triangle but it's not isosceles, something like that. They'll tell you to prove one thing but prove that it's not another. And so our essential question is, how can we prove a shape is not a particular shape using coordinates? Pause the video if you need to write that down still. If you're asked to prove not a shape, you must still make the full table, and that's coming from skill 8.2. And think about how the quadrilateral is the shape, and then use your table to show that it doesn't work. So in order to prove that it's not a rhombus, we need to show that there are not 4 congruent sides. Again, that's a not 4 congruent sides. To show that it's not a rectangle, there needs to not be a right angle. To show that it's not a square, no 4 congruent sides, and not a right angle. And again, you can think of your PRS, P-R-R-S. P, parallelogram, goes into R, rectangle, or R, rhombus, and both come to make the square. Properties carried down, remember. Not an isosceles trapezoid means there are not congruent legs. That one is the least common of things that you're going to be asked to prove, so don't stress yourself out about that. Not an isosceles triangle means there needs to not be 2 congruent sides. Isosceles means 2. Equilateral means 3. So all 3 sides should not be congruent. That doesn't mean they all have to be different. There just needs to be at least one different side. And not a right triangle, of course, not a right angle. Now you're maybe wondering, like, well, how do I get not things? So let's talk off to the side. If you want not a right angle, well, right angles come from perpendicular lines, so you want no perpendicular lines. And perpendicular lines have certain kinds of slopes. Perpendicular lines have op-recip slopes, so we want no op-recip slopes. So that's not a right angle. If we want, we didn't mention this at all over on the right side, but if we want not parallel, that would mean that we want not same slopes, because parallel lines have same slopes, so we stick the word not in front of it. And the last thing that we were concluding was not congruent. If we want things to not be congruent, they need the not same length. So as it said, we are still going to make the table, and in this first problem it says, given the table below, prove that it's a rhombus but not a square. So you know that a rhombus has 4 congruent sides, just like a square does, but the difference between a rhombus and a square is that a square has a right angle, but we don't want it to be a square, so there needs to be no right angle. So now we're taking a look. This chart was already made for you. You're welcome. We just saved you a bunch of time. And we're going to make those little conclusions in the table itself. So remember our steps from last video. First step was plan. Second step is table. Third step are conclusions. So I'm going to look at my Pythagorean theorem first. I know normally our table is flip-flopped from this, right? We normally do change x, change y, and then Pythagorean theorem. So I'm going to stick in this Pythagorean theorem column for just a minute. I noticed that I have square root 26, square root 26, square root 26, square root 26. So you should have a colored marker right now circling each of those. And then also indicating that all of these square root 26's mean that the segments are the same length. Or in other words, they're congruent. Which is fabulous because we wanted a rhombus with 4 congruent sides. Then I take a look here and I see at the slopes 1 over negative 5, which is the same as negative 1/5, and another negative 1/5. Those two are parallel because they have the same slope. Then I take a look and I see 5 over negative 1 and 5 over negative 1. These are also parallel because same slope. But remember, we want this to not be a square, so there needs to be a not thing in the conclusions that we make. And in order to not have a right angle, we need not perpendicular lines. And that means that we want not op recip slopes, meaning that they don't want to be flipped and negated. So if I look, say here, I have 5 over -1 and -1 over 5. They're both still negative. Even though the fraction flipped, they're both still negative. So that means that it's not an opposite reciprocal slope, so we're going to say not perpendicular. I could have also made that same conclusion up here or down here. It doesn't matter. None of them are opposite reciprocals. So now moving on to our fourth step, we're going to say ABCD is a rhombus, but not a square. Because there are 4 congruent sides, but no perpendicular lines, so no right angles. Okay, so you say what shape it is or what shape it is not, and then you give a justification. Why? Using properties. Is it what it is, or is it not what it's not? That sounds confusing. But again, go through your steps, make your plan. Step 1, make your table. Step 2, make your conclusion. Step 3, get a not in there if it says that it's not a particular shape. And then step 4, make your final conclusion. We're going to see another example of this on the back side. Kelly is experimenting with a new drawing program on her computer. She created quadrilateral math, and Kelly believes that she has created a rectangle but not a square. So let's first pause and plot this, because sometimes it's helpful to see it. You may not do the graphic option for finding your changes in X and Y, but seeing the figures so that you can recognize it is in fact a rectangle but not a square is sometimes helpful. So again, pause, plot, and then hit play. Pause, plot, play. All right, so I have it plotted and labeled. So now I recognize that it says it needs to be a rectangle, which this looks like. But remember that a rectangle has the following properties. Op, sides, parallel. So like TH is parallel to MA, and TA is parallel to HM. And it also has a right angle. So this is step 1 that we're taking here, planning. Then it says that it's not going to be a square. What's special about a square? How do I take a rectangle and change it into a square? Well, it still has right angles. It still has opposite sides parallel. But the difference is that the length of all of the sides should be equal. So here I want to say not 4 congruent sides. Sometimes drawing the 2 separate pictures helps you to recognize what's true from both and what's the difference between the 2. So now we're going to make our big chart. I always start with the far left column and I do my sides first. So MA, which is at 1, 1, and 5, 3. AT is the next segment, which is 5, 3. And 4, 5. TH, 4, 5, 0, 3. And MH, 1, 1, 0, 3. Okay, so then we have change X, change Y. A squared plus B squared equals C squared. Again, give yourself a little bit more space so that you can make your conclusions right in the table. And then slope, change Y to the sky over change X. All right, so I'll do the first one with you, and then I'll put you to work after that before you can check your answers. So the first one, change X, I do 1 minus 5 gives me -4. And then change Y, I do 1 minus 3 gives me -2. I plug both of them into the Pythagorean theorem, and I have 4 squared plus 2 squared equals C squared. And then I get c equals square root, because I know that's what I'm going to have to do eventually. 4 squared and 2 squared sum to 20. Seems to be the most common thing that we've been doing in these videos. I'm sorry for the repetition. Change y is 2 over change x is negative 4, which reduces to positive 1/2. Negative divided by negative is positive. Okay, so you're going to pause. You're going to work on the rest of this table, and then we can come and make conclusions together. So hit play when you are done with the table. All right, here's my table. Hit pause if you want to check it more thoroughly, but I got square root 5, square root 20, square root 5, just going down the list. And then for slopes, I had negative 2 over 1, 1/2, and negative 2 over 1. So now we're ready to make some conclusions about what we see. So again, we're trying to show that this is a rectangle but not a square. So I notice that I have square root 20, so I can conclude something about those. Go ahead and try to make that conclusion and then check your answer. You should have written that they're congruent. Then I have, let's see, trying to grab different colors here. Square root 5, so those are the same length, which means they're also congruent. But we're trying to make this not a square, so I need a not conclusion in this, which means that I want to show that not all the sides are congruent. I have square root 20 and square root 5. Again, you're using colored markers here so that this stands out to you. Square root 20, square root 5 are clearly not congruent. Okay, so that's cool so far. I have opposite sides congruent and one pair of sides that are next to each other that are not congruent. Fabulous. But remember, we also need a right angle and we need parallel sides. So I look at my slope column and I see 1/2 and 1/2, and those tell me they're the same slope, so that means that they are parallel. Please, please, please do not tell me that same slope means congruent, because that is entirely false. Same slope means they rise and run at the same rate, meaning they're parallel. Never going to cross. Then I see negative 2 over 1, negative 2 over 1. Those are parallel. Cool beans. But wait a second, we still need a right angle. And I notice I have a positive 1/2 and a negative 2 over 1. Positive 1/2, negative 2 over 1. That tells me these are perpendicular, because they are flipped and negated. If you are still not sure what flipped and negated means, then you need to either A, go back to the 7.5 or 7.6 video, or B, ask your teacher. Because flipped and negated is something you should know at this point in time. You flip the fraction upside down and you change positive to negative or negative to positive. All right, so we've done step 1, we've done step 2, we've done step 3. Now we're on step 4. Write the final conclusion. Hopefully you still have some space at the bottom of your paper. If not, you can write your conclusion off to the side or wherever you have space. But please don't use your summary box like I'm about to do. Okay, you're going to need to do your summary later. Okay, so for me, I'm going to say that math, M-A-T-H, is not trash, by the way. Math is, however, a rectangle. And life. Math is life. Math is a rectangle, but not a square. Because, now we're going to just explain what we found. We found that opposite sides were parallel. Opposite sides are parallel. We found that there were perpendicular lines forming a right angle at, and in this case, because I used these two, the common letter is A, so angle A is right. Not like right as in it's correct, but right as in 90 degrees. Okay, so opposite sides parallel, perpendicular lines forming congruent right angles. You can conclude about the opposite sides being congruent. It's not necessary. But if you do it, that's fine. We did find that. But then we have to say the not part. but not all sides are congruent. Because remember, we made that little conclusion about how we had not congruent square root 20, square root 5. They're not the same. They're not congruent. Let us know if you have questions. Don't forget to do practice and write your summary. I know that these charts take a while, but again, as I said in the last video, you are capable of doing the chart. It's the conclusions that you need to really focus on. Okay? Let us know if you have questions. Good luck.